When the Carrington event occurred in 1859, a lot of people thought it was the end of the world. Should a similar event occur today, you might well believe that it is the end of the world as we know it. Maybe not forever, but it will be quite profound. I'm going to tell you what the Carrington event was, what caused it, what it caused, and what consequences we could have from such an event today. I'm drawing on information from YouTube, where there is an overview of the whole thing, Wikipedia likewise, and some of the other information I've gleaned from NASA in the United States. Richard Carrington was an astronomer, and he specialised in sunspots. And one day in August 1859, he saw an intense, very bright area on the screen that he was working on. And it turned out that this, in fact, was a solar flare. A great emission of visible light and other radiation which left the sun and arrived on Earth after just over 8 minutes, which is the time it takes for light to get here from the sun. But in addition to that, at the same time, there was a coronal mass ejection, which is very like a volcano on the surface of the sun, and that poured out plasma, charged particles, magnetic particles. They took quite a lot longer to get to the Earth, and it took them 17 hours to actually arrive. Now the Earth is hit by solar particles, charged particles, all the time in various intensities, and they're mainly repelled by the Earth's magnetic field. That is particularly intense at the poles, at the North Pole and at the South Pole, and when these solar storms occur and they actually coincide with the magnetic radiation or magnetic waves at the poles, you get the aurora borealis in the north, the northern lights. You get the aurora australis in the south, the southern lights, I suppose they call them. Now on this occasion, after the 17 hours when the solar storm arrived at the Earth, it was so intense that the aurora in the south could be seen in Australia. The aurora in the north could be seen as far south as the Caribbean. And it was so bright that gold miners in the Rocky Mountains got up and made breakfast because they thought it was morning. And other people thought it was the end of the world. In 1859, almost nobody used electricity. It wasn't until 20 years later, 1879, when the light bulb became commercially available. So there was no electricity distribution infrastructure. There was no national grid or anything like that. But there was a telegraph system. Telegraph wires on poles went for hundreds of miles across continents, and little men in telegraph offices hammered away on their Morse keys, sending messages across the world. When the solar storm hit the Earth, it caused power surges in these telegraph wires. The people in the telegraph offices found sparks coming out of their equipment. They disconnected the batteries. They found their systems would still work. In one office at least, they continued sending messages for 2 hours without the batteries being connected. So how did this work? Well, you may remember from your school physics that if you move a magnet past a conductor, past a piece of wire, you induce a current in that wire. And this is what was happening. The solar charged particles were streaming past the wires in the telegraph system, and they were causing a power surge. Now suppose this happened today or tomorrow. We've got a completely different infrastructure. We have, over most continents, got high voltage infrastructure pylon lines. And if a solar storm of the intensity of the Carrington event were to occur, it would induce currents in those lines. It would probably affect anything which was a conductor. It could affect any electrical or electronic device, depending on the intensity. It would be extremely important for people who run the national grid to disconnect the transformers at either end of the line, because the surges could destroy those transformers. And we're talking about units which cost hundreds of thousands of pounds and take months, if not years, to replace. And I haven't mentioned, of course, the first port of call for any solar flare. It would hit the communication satellites around the world, first of all, and could knock out our communications. well, how likely is it to happen again? Well, it has happened. In 1989, there was a similar event, not as strong, but it was strong enough to knock out the national grid, the power distribution system in Quebec, in Canada. Only for a short time. They only lost it for a day or so, but it happened. And in 2012, there was a solar eruption, a coronal mass ejection, every bit as strong as the original Carrington event, and that came out of the sun straight through the orbit of the Earth, but fortunately part of the orbit that the Earth wasn't in at the time, so we missed it. But if the Carrington event occurred again, or something similar occurred, don't worry about Brexit. Don't worry about climate change. You'll know that something serious